Hey guys, welcome to 11.9. This is our last chapter or last section of the trimester. So congratulations, you've almost made it through. We're going to conclude our chapter about statistics and probability. We're talking about normal distributions. Normal distributions play a role in your life. For example, if you look at IQ, IQ is all based around normal distribution. If you look at SAT and SAT and ACT scores, those are also based around normal distributions. The MCAs that you're going to take in a couple months, those are based around normal distributions. And so they do play a role in your life a lot with test scores, but then there's also some other applications to them. So we're going to our essential question: how do you use a normal distribution? All right, so let's talk about first some vocab here. A discrete probability distribution has a finite number of possible events or values. Okay, so a finite number means that there's only a certain amount of possible events that could happen or values. So if you look here, it says the title of this graph is possibility of the number of heads, or the probability of the number of heads in 3 coin tosses, right? So the possible number of possible events is pretty limited with a coin toss, and you're only doing 3 of them, right? So you could either have heads 0 times, 1 time, 2 times, or all 3 times, right? Okay, now we also have what's called a continuous probability distribution, and it can be any value in the interval of real numbers. And so you could, it kind of goes on. You notice this graph does not actually touch down on the axis, right? Because there's a super small chance, by the looks of this graph, super small chance that there could be a number out here, right? Now that's not nearly as good as in here, but it's still a chance. So you're saying there's a chance. Yes, I am. All right. Sorry, guys, it's 8 o'clock. I'm so tired. All right. A normal distribution. Okay, that's what we're focused on this section is normal distributions. A normal distribution has data that is random, that varies randomly from the mean, from the average. Okay. The graph of a normal distribution is called the normal curve, or a bell curve is what it might be described as. It looks something like this. It looks like a bell. That's why it's called a bell curve. This would be a normal distribution, a normal curve. Okay, you'll notice this is the mean. It's also, if it's perfect, it's also the median, and again, if it's perfect, it's also the mode. And then everything, 50% of the data is above that line and 50% is below that line, so it's symmetrical. That would be in an ideal world. Okay, now things don't always happen nicely. Here's our perfect world situation, but then there are times where your data gets skewed left, and that's where it looks a little bit like this, where the mode and the median are on the right side of your mean, but then there's also skewed right. And I know you're thinking these are backwards. Think of it as where the mean lies. Okay. So if it doesn't look like a nice curve, then it's not a normal distribution, and a lot of these rules don't really apply. All right. You track, so our first example, you track the number of words in your text messages for a month, and then you sketch the bar graph shown. Okay, and you have our little curve. Now, it does look pretty normal, so we're good to go. The number of words is normally distributed about a mean of 10. So what that means is that it is a normal distribution, and the mean is 10. That is a fantastic line I got going on. All right, so 10 is our average. Let's use this instead. Okay. So we need to figure out about what percent of your text messages are between 9 and 11 words long. Okay, so 9 and 11 words long. We need to figure out what percent. Now, if you add all of these up, it's going to be 100%, right? If you add every single possibility up. But what we're going to do, we only want the 9, 10, and 11s, right? If you look at our y-axis, it says percent of messages. Since it says percent, it's actually really nice. And so what we're going to do is we're just going to add these 3% together. Okay, and I'm going to get rid of a little bit of the clutter here for us. Okay, so if we look at the 9-word messages, that's what we'll call it 18%. Okay, now how many 10-word? 20%. And then how many 11-word? Again, 18% is normally distributed. I'm sorry. We add all those together. It's looking for the total percent, and that's what 56%. So 56% of the text messages are 9 to 11 words long. All right, what percent of text messages are more than 13 words long? Ooh, okay, so more than 13. Okay, now take a look at the wording. It does not say including 13. It says more than, right? So what we're going to do here is basically we're just going to add up what we know. Yes, there are minuscule amounts after the fact, but we're just going to add up the data that we're given. Okay. And so 14 looks to be about what? We'll call that 3%. And then 15, probably 1%, right? Equals, so what percent of the messages are more than 13 words long? 4%. Now, if you look on the notes on Schoology, Miss Levering actually included the 13s, but the keywords here are more than 13. You know, if it said 13 or more, then you would include the roughly 8% that the 13 includes. All right. So this bar graph gives the weight of a population of female brown bears. The curve shows that they are normally distributed about the mean, which is 115 kilograms is the average weight. Okay, so we need to figure out approximately what percent of female brown bears weigh between 100 and 139 kilograms. Okay, so 100, that's our bottom limit, and 139 would be the top limit of right here, correct? I believe so. Okay, well, to do this, we just add them all up. Percent-wise, again, percent of bears, 20, we'll call it 24%, plus, how much is in this one? 40, I don't know, 40, probably 42%. And then back to this one, 24 again. Okay, now we're going all the way up to 139, so we also have to include this, which that's easy, that's 5. Okay, we add all of those up. Let's see, that'd be 80, no, hold on, 88, 90 plus 5 would be 95%. Check my math on that. It's late and I'm exhausted. All right, now some key concepts here. When you're looking at a normal distribution, yesterday we looked at standard deviation. And if you go one standard deviation away from the mean, you're going to actually get 68% of the data will fall within one standard deviation. Okay, 95% will fall within 2 standard deviations, or 2 iterations, I guess, from the mean. The 95% will make it all the way out to there. Now, if we extend it to 3 standard deviations, we're looking at 99.7% of all the data will fall within 3 standard deviations. Okay, so for an English class, the average score on a research project was 82, and the standard deviation of the normally distributed scores was 5. Okay, so we got a standard deviation of 5. Okay, we got an average of 82. All right, sketch the normal curve showing the project scores for the 3 standard deviations of the mean. All right, so we start off with excuse me, an x-axis, and then we know that our median is going to be at what, 82? Now, one standard deviation away from that, if we have a standard deviation of 5, we add 5 and we're going to get 87. Go the other direction, we're going to get, 77? Okay, so if we were to draw our normal curve, I'm going to do the best I can with my little mouse here. Oop, well, sure, we'll roll with it. Okay, for the sake of time. All right, so one standard deviation away will be at 87 and 77. Okay, now if we went 2 standard deviations away, oh, sorry, we should label this. So this is plus 1 standard deviation. This is minus 1 standard deviation. All right, then we add another 5 from here, and that gets us to what? 92. Okay, that's 2, so that'd be plus 2. And then we subtract here, we're going to get 72. And try to make this as symmetrical as possible. That's minus 2 standard deviations away. Okay, and then if we want to go 3 standard deviations away, we we subtract in this case another 5. That would get us to 67. So that's minus 3 standard deviations. And same thing here, we add 5 in this case, so we get 97. That's a plus 3 standard deviation. All right. Now, if you remember back to this graph here, we got 34% on each side, and then 13.5, and then 2.35. You can just reference back to that as you need. All right, so 34%, 34, 13.5, we're in here. 2.35 are in here. All right, and same thing on this side. 13.5 and 2.35. All right, now to answer the questions, last slide, good. All right, so using your normal curve, what percent of students scored between 72 and 82 points? Okay, so what percent? Well, between 72 and 82. So what we're going to do is 13.5 plus 34. Okay, and so we know that 47.5% of students scored between a 72 and an 82. Okay, using the curve again, what percent of students scored between an 87 and a 97? Okay, so 13.5 plus 2.35. Okay, and again, I don't want you to get stuck on where did Cook get these numbers from. It's from your chart. Okay, this is just how a normal distribution works. Okay, hopefully you have this in your notes. I really hope you do. If not, pause the video, get them, write them down, and this as well. This would be good for you as well. All right, this was a 3. All right, now that is what, 15.85%. Okay, using a normal curve, what percent of students scored between a 67 and a 72? We'll start off with that 67 and 72. That's 2.35%. Okay, if there are 42 students in the class, about how many scored within this range? Okay, well, first off, we need to turn this into a decimal, and so it's going to be 0.0235. And then there's 42 students, so we're going to multiply by 42. And that gets us 0.0235 times 42 is 0.987. In practical terms, that's about 1 student. 1 student dropped below that 3 in the minus 3 standard deviations away. All right, that's it for section 9. Make good use of your work time, guys. Get a lot done. You have a lot of missing work to catch up on. So please be productive and end this trimester on a good note. All right, and I'll hopefully be back next week. For sure, I'll be back next week, but hopefully I'm back right away on Monday. All right, have a good weekend, guys.